Let's look now at the semantics of multiplicative situations, meaning the structure of the situation. We're going to ignore temporarily uh, how kids solve it. We're just looking at the situation itself and organizing all possible situations into two main groups, asymmetric and symmetric. Okay, so the most typical problem that we see in our textbooks are what are called asymmetric situations, and the most of the most are these grouping problems. Let's take a look at what I mean by a grouping problem. Here we go. Sean has 7 boxes of crayons. There are 6 crayons in each box. How many crayons does he have? Very typical problem. You've seen this over and over. There's 5 bookshelves with 3 books on each shelf. There's 7 classrooms with 20 students in each classroom. There's 5 nests with 3 eggs in each nest. All right. So kids see this problem a lot. All right. Why do we call it asymmetric? Well, because our two factors happen to be group, how many in each group. Okay. So here we have boxes and crayons, and my product will be the number of crayons. Well, those factors have different labels, and they play very different roles. For example, I couldn't take my 42 crayons and shove them into 6 boxes. They wouldn't fit. The one label is boxes and one label is crayons. They're not the same, asymmetric. Another type of asymmetric problem is the rate problem. For example, Kristen bought 5 pencils that cost 4 cents a piece. How much did she pay? Again, not interchangeable. One factor is pencils and one factor is pennies. Not the same thing. The third, and we're not going to talk about these. Rate problems are much more difficult than the grouping problem, and they're not going to be part of our discussion. And even more difficult than rate problems is the asymmetric problem. It's the scalar problem, talking about scaling. Okay, Corey has 3 times as many seashells as Sheila. Corey has 12 shells. How many seashells does Sheila have? What's so difficult about scaling problem? You really need to starting to hint at proportional reasoning, which our K-5 kids aren't really ready for. And notice how I don't really see my factors. Okay, can't really see there the difference between Corey's collection and Sheila's collection. I do want you to know. So the grouping's most important for us, but I do want you to know, of course, there are other asymmetric situations. All right, so refocusing on the grouping, how do you think kids would solve this? They're probably going to do 6 plus 6 plus 6 plus 6 plus 6 plus 6 plus 6. When kids see a grouping problem, they typically do a repeated addition. They might have some more efficient ways of doing that, um, grouping the grouping. But what I find so interesting is that there's no reason to multiply here. Kids, the grouping problem nudges you to use repeated addition. Okay. So the bulk of the problems, which are grouping, don't even really make kids multiply, and that's a really important element of this. There's all kinds of grouping activities I'm sure you try in your classroom. You probably play circles and stars, great activity from Marilyn Burns here. And that is either individually or in pairs, kids are making groups and putting stars in those groups. So you play with 2 dice, ideally 2 different colored dice. The first die you roll tells you how many circles to draw. So here this boy rolled a 3. He makes 3 circles, rolls a 2, um, places 2 stars in each of those circles, and then figures out how many stars in all. What I'd like you to do is look at this collection of written work. I played circles and stars with first graders because grouping problems, all symmetric problems, almost encourage you to do a repeated addition. It's absolutely fine to introduce these activities at a younger age. So take a look at the written work. What I want you to look for is just from looking at their work, can you figure out their solution strategies?